Module 1, Lesson 2, Multiplying Numbers in Exponential Form. So today we are going to go through the lesson, and we will only be doing certain ones for the time that we have allotted. But the first thing we want to start off with is just an example in numbers here. They give you an idea of a general idea down here, but sometimes it helps to see it in numbers. So we're going to start with an example. Let's say that you have 5 to the second power times 5 to the fourth power. What that really means is that you have 5 times 5 here, times over here now you have 5 times 5 times 5 times 5 4 times. So in all, you're really multiplying 5 by itself 1, 2, 3, 4, 5, 6 times. So your answer here is going to be 5 to the 6th power. And so many of you will be able to see that you don't have to write out all of the 5s. There is a shortcut when multiplying numbers of the same base with the exponent, and that is that if you add the 2 and the 4 here, if you add those up, you will get 6. So you keep that same base and you add your exponents when you are multiplying. Okay, so for example, exercise 1, 14 to the 23rd power times 14 to the 8th power. You're going to keep the 14 because it has the same base, and then you will add the 23 and the 8 and get 31. So you get 14 to the 31st power. And the same is going to hold true for negative numbers. So you'll keep the negative 72 in parentheses and add the exponents. 10 plus 13 is 23. And it doesn't change again if you have letters. So if you skip over to exercise 5, a to the 23rd times a to the 8th, you keep a as the base, and then your exponent is going to be 31. You add that 23 and the 8. And so that's the first kind of main point to introduce the lesson. If you flip the page to page 6, there's several more exercises of similar looking problems. Okay, so exercise 9 is very close to what we were just talking about, except for now you have 3 base 9s. In exercise 10, you have 4 base 2. You're going to do the same thing here, except for you're going to add 3 sets of exponents instead of 2, or 4 sets of exponents instead of 2. So this one, for example, you're going to keep the 9 as the base since they're all 9s, and you'll add 4 and 6 and 13 and find out that that's 23. And so this is what you end up with. Okay? As we move on, we're going to start getting bases that are not the same. But you can see that we have a 6 as a base and another 6 as a base and a 4 as a base here and a 4 as a base here. So in this case, what we want to do is we want to combine the like bases. So there's really 5 6s multiplied by themselves here and 14 of them multiplied by themselves here. So what you want to do is combine that to get 6. Add these two. So we're going to add the 5 and the 14 to get 19. So those are taken care of. And then we're going to say times now, and we're going to put a separate spot for our bases of 4. So we're going to put our base 4, and we will add the 9 and the 3 to get 12. And this is then our final answer. We don't put them together because they have separate bases. And the same rule is going to apply for exercise 12 and 13. When you have separate different bases, what you're going to end up doing is you are going to add the exponents of the like bases. Okay? I want to put my own example on exercise 14 here because I know what's coming in your homework. So let's say you have 5 to the second power times a to the second power times b times 5 to the third times b to the fourth. Okay? This is the same idea again. So we want to add the exponents on like bases. So 5 and 5, there are 2 of those. We're going to keep that base, and we'll add the exponent. So we should get 5 to the 5th. Now, the first thing that's different here is there's not another a base. So if that's the case, this still has to go on your answer, but there's nothing to add to it. So a to the second power is just going to stay the same. Now, the third thing that is different here is that this b is a match with this, but there isn't an exponent on it. So anything that doesn't have an exponent technically does have an exponent, and it's a hidden 1. So that's really b to the 1 power and b to the 4th. If we combine those, we would get b to the 5th. And then our final answer looks like this. So that's our second concept, really, is what do we do with when we have several different bases. Now, as we continue down, we're going to skip to exercise 17 and 18, really. And in 18, I'm going to use my own example, so I'm going to cross this one out, and we're going to use 2 times 4 plus 2x. But back to 17. Now, something to note is that anytime it's written like this and it's all kind of jumbled together, you can separate them, and I recommend you do that. This is really 2 times x to the 3rd times 17 times x to the 7th. Okay, and so that makes it look more like something we're familiar with. So the difference here is that I have 2 numerical bases that are not the same. I have a 2 base and I have a 17 base. If that happens and they're not the same, you multiply them together. Okay, so 2 times 17 is 34. And so that's what we're going to start our answer with. And then you're left with bases that do match up. We have an x base, and so we're going to do like we did before, and we're going to add those exponents, that 3 and that 7, and get x to the 10th. And so the note you want to put in your notes here is going to be that if you have unlike bases, and they are both numbers, you can multiply those together. Okay, the last really thing we're going to talk about in this lesson is what to do with distribution. So we're going to use the distributive law or the distributive property to answer the next questions. So I want us to go ahead and change your example to look like this, 2 times 4 plus 2x. So what we do when we distribute is we are really distributing the one on the outside of the parentheses to everything on the inside. So you want to take this and you multiply it first by the first term. So 2 times 4 is 8. Then we look here, there's a plus, so we're going to pull a plus down. And now we're going to distribute this to the second one. 2 times 2x is 4, and then you have to include that x. And that's your answer. You cannot add the 8 and the 4x because there's not an x on that 8. Now, what does that have to do with our exponents? We're going to find out here in exercise 19, which I'm also going to have you change. So exercise 19 on page 7 then is where we're at. So we're going to change exercise 19 as well. And we want it to say, or I'm going to have my class make it say, instead of this, we're going to have it say x times 3x plus 8. And if you recall, I told you that there's a hidden 1 on these values. So we're going to distribute this again. So if I distribute x times 3x to the 1, what you really have here is x to the 1 times 3 times x to the 1. Okay? And so we can combine this x to the 1 and x to the 1 to get x to the second power. Those are like. And this 3 then, the number is going to go in front. That's just the notation we use. So that deals with the first term. Okay, now we have to deal with distributing again. So we're going to do x to the 1 times 8. So just like before, we want to multiply that. So x to the 1 times 8, there's nothing that we can combine here. But to be correct, we want to put the number in the front and the x or the x to the 1 in the back. And what you want to make sure then is you put your plus back in the middle. And here's your answer. Okay, and so that it can get a little bit confusing there. You just have to make sure you distribute and see if you can add some exponents in any of the terms. The last thing we're going to do today is exercise 20, and we're going to replace that one as well. So exercise 20, let's replace with a plus 4 times a plus 5. This is also distribution, only you're going to distribute twice. I like to tell my students that you should think of it as this is a set of boys and this is a set of girls, and they're in a dance troupe. And each boy has to dance with each girl, okay? So let's start off. This is really a to the 1 and a to the 1. So this boy is going to first dance with this girl, right? So we end up with a to the 1 times a to the 1, okay? So we know by what we just learned that we can make that a squared. We can add that up, okay? And so I'm going to cross that out so I know that I've used that. The next pairing then, this boy, this a to the 1, still has to dance with this girl, okay? So a to the 1 times 5 is what this looks like. There's nothing we can actually put together on this one, so we're going to write it in the correct notation by writing the 5 first and the a to the 1 second. Now, this boy is not going to be left out. He's also going to dance with each girl. So first, this boy is going to dance with this girl, dance with the a. So that one's going to be 4 times a to the 1. Again, no exponents to be added, so we're going to write it with the number in front and the a to the 1 as second. And there's one last pairing then. This boy, this 4, is going to dance with this girl, this 5. And so that's really 4 times 5, and we want to make that simple as possible. So 4 times 5 is actually 20. Now, eventually, we will talk about and learn that these two middle terms can then be added together. But for today, we're going to leave our answer like this, okay, so that we can just focus in on adding the exponents, and that's the important part of the lesson. So tomorrow, we will do the second half of this lesson, which is the division, starting with exercise 21. But for today, that will conclude our lesson. You'll be looking for this worksheet as your homework then on the website. It is titled Exponents and Multiplication. If you have questions, please make sure that you email me or that you come see me in the morning.